Hello and welcome back to Geometry, Chapter 6, Section 5. We're talking about indirect proof and inequalities in one triangle. Alright, so in your book there's an example of a kid who comes into the cafeteria and it's Tuesday and Tuesday is hamburger day. Well, he walks into the cafeteria and gets this feeling that today must not be hamburger day. So he's looking around and he realizes a difference from hamburger day. Usually on hamburger day there are ketchup bottles on the tables. But today there are no ketchup bottles on the tables. So, based on this, he determines it must not be hamburger day. That's what we call an indirect proof. Alright? For an indirect proof, first, you identify the statement you want to prove. It's not hamburger day. Now, temporarily, he assumed, okay, what if this was hamburger day? If it was hamburger day, then there would be ketchup bottles on the table. And then he looks around and proves, since there are no ketchup bottles on the table, so it must not be hamburger day, as he determined to begin with. So there we go. If we want to write an indirect proof that there can at most be one right angle in a triangle. Alright, ABC is a triangle. We will temporarily assume that the opposite is true and that this triangle has two right angles. So we will say angle A and angle B. If angle A and angle B are right angles, they each equal 90 degrees. Therefore, angle A plus angle B equals 180 degrees. Since all the angles in a triangle add to 180 degrees, that would make angle C 0 degrees. That's not possible. Therefore, there can at most be one right angle. Alright, relating side length and angle measure, ordering angle measures. Okay, here we have a triangle A, B, C. Okay, now notice the longest side here is from A to B. Okay, this is my longest side. It is across from the largest angle. Okay, let's investigate. I'll let you go ahead and put in order from largest to smallest. Angle A, angle B, and angle C. Order these from largest to least. Go ahead and pause the video and do that. Okay, so you'll see the smallest side, shortest side here, is opposite the smallest angle. And so the largest angle is angle C. Angle C, opposite the largest side. The middle angle is angle B. And then the shortest, the smallest angle across from the shortest side is angle A. So in order, C, then B, then A. Okay, so the triangle longer side theorem, if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Right? That's what we just looked at. This side, AB, is longer than BC. Therefore, angle C is greater than angle A. And the other way around, the larger angle theorem, if one angle is larger than another angle, then the side across from it must be longer. So since this angle is larger, the side across from it is longer. All right, now you can't just take any three measures and make a triangle. Okay, here's a triangle with side lengths 2, 4, and 5. You can make a triangle out of those side lengths. But here are lengths 2 and 2. I can't make a triangle out of 2, 2, and 5. Because these two measures, if I take 2, they don't connect. These two sides wouldn't connect. They would just fall to here. Okay, same thing here. 3 and 2. Now 2 and 3 add up to 5, which would mean they would lie exactly on this side. So the two other sides have to add up to more than the third side. So 2 plus 4 gives me 6. If I add these two together, that gives me 6. And that's more than 5, because if it's exactly 5, then that would just make a straight line. If it's less than 5, they could never touch. Okay, so two sides added up together, the sum of two sides have to be greater than the sum of a third side. That's the triangle inequality theorem. All right, so we want to find possible side lengths. We have one side that's 14 and another that's 9. Okay, so if we make a triangle, okay, we call this one 14, call this one 9. All right, now 14 plus 9 have to be greater than x. So 14 plus 9 together must be greater than x. Okay, so 14 plus 9 gives me 23. So x has to be less than 23. But 9 plus x, these two together, also have to be longer than 14. So 9 plus x have to be greater than 14. So if I subtract 9 here, x has to be greater than 5. So x has to be less than 23 or greater than 5. So 5 less than x, which is less than 23. Okay, x has to lie in between 5 and 23. So those are possible lengths. Anything greater than 5, anything less than 23 would be possible to make a triangle. And that's all we have for today. Ladies and gentlemen, check in again next time for another fun lesson.